Hi everyone, I'm Professor Sri. Welcome to the session on rubber. Subscribe to the channel to check out more videos relating to engineering and management, science and technology stuff. This session, the topic of discussion is rubber. The content of the session are rubber introduction, natural rubber, tapping and coagulation, applications, synthetic rubber, emulsion polymerization method, different synthetic rubbers, applications in aeronautics. Rubber, elastic substance obtained from the exudations of certain tropical plants, which are natural rubber, or derived from petroleum and natural gas. They are synthetic rubber. Because of their elasticity, resilience, and toughness, rubber is basic constituent of tires used in automotive vehicles, aircrafts, and bicycles. More than half of all rubber produced goes into automobile tires. The rest goes into mechanical parts such as mountings, gaskets, belts, and hoses, as well as consumer products such as shoes, clothing, furniture, and toys. The main chemical constituents of rubber are elastomers. We have discussed in the topic polymers. Elastomers are also called as elastic polymers. They are large chain-like molecules that can be stretched to great lengths and yet recover to their original shape. The first common elastomer was polyisoprene, from which natural rubber is made. Formed in a living organism, natural rubber consists of solid suspended in a milky fluid called latex that circulates in the inner portion of the bark of many tropical and subtropical trees and also shrubs, but predominantly Heva brasiliensis, a tall softwood tree originating in Brazil. Natural rubber was first discovered by the great Christopher Columbus during his second major voyage, but was scientifically described by Charles Marie de la Condamine and Francois Fresnel of France following an expedition to South America in 1735. The English chemist Joseph Priestley gave it the name rubber in 1770 when he found it could be used to rub out pencil marks. Its major commercial success came only after the very famous vulcanization process of rubber, which was invented by Charles Goodyear in 1839. The surprising fact is that the famous tire manufacturing company Goodyear, apparently, he was the inspiration for the company. Natural rubber continues to hold an important place in the market. Its resistance to heat buildup makes it valuable for tires used on racing cars, trucks, buses, airplanes, and everywhere. Tapping. When the bark of the rubber tree is partially cut through or called as tapped, a milky liquid exudes from the wound and dries to yield a rubbery film. The biological function of this latex is still obscure. It may help wound healing by protecting the inner bark, or it may serve for other biochemical functions. The latex consists of an aqueous suspension of small particles about only 0.5 micrometer in diameter of cis polyisoprene, a linear rubbery polymer of high molecular weight. The rubber content of the suspension is about 30%. After collection of the tapped latex, rubber is recovered from emulsion by coagulation from formic acid, creating crumbs that resemble curds of milk. The crumbs are washed, dried between rolls, and compacted into blocks. The blocks are then wrapped in polyethylene sheets and packed. Other production is as smoked sheet, where the coagulum is pressed into thin sheets that are washed and then dried over a smoky wood fire. The smoke contains natural fungicides that protect against mold growth and impart a characteristic amber color. Finally, packaging these thread sheets. Natural rubber is used in applications requiring a high level of wear and heat resistance. Thanks to its strength and compressibility, natural rubber is used in engineering applications like anti-vibration mountings, drive couplings, springs, bearings, rubber bands, and adhesives. But the majority, 50% of natural rubber, is used in high performance tires for race cars, buses, and aircraft tanks because of its high strength and heat resistance. It's also used in hoses, automotive parts, foam mattresses, and battery boxes. Because of its adhesive properties, natural rubber is also found in rubber cements and the soil stabilization materials used around new road constructions. Even raw rubber is sometimes used for adhesives and as part of shoe soles. Additionally, about 10% of latex harvested from the trees is simply reduced down to 60% rubber solution to make products like latex gloves or to use as a coating. As we discussed, natural rubber is a general purpose product. However, its sustainability for aircraft use is somewhat limited because of its inferior resistance to most influences that cause deterioration. Although it provides an excellent seal for many applications, it swells and often softens in all aircraft fuels and in many solvents. It is used as a sealing material for water or methanol system in aircraft. But comparatively, natural rubber deteriorates more rapidly than synthetic rubber. Now, welcome to the world of synthetic rubber. Synthetic rubber is available in several types, each of which is compounded of different materials to give the desired property. The most widely used are the butyls, like tire tubes, bunas, like washers, and neoprene, like timing belts. Emulsion polymerization method. Monomer molecules and free radical initiators are added to a water based emulsion bath, along with soap like materials known as surfactants or surface acting agents. The surfactant molecules, composed of a hydrophilic and hydrophobic end, form a stabilizing emulsion before polymerization by coating the monomer droplets. Hydrophilic, which is water attracting, and hydrophobic means water repelling. Other surfactant molecules clump together into smaller aggregates called micelles, which also absorbs monomer molecules. Polymerization occurs when initiators migrate into the micelles, including the monomer molecules, to form a large molecules that make up the latex particle, which in turn gives you the synthetic rubber. This is one of the manufacturing methods of synthetic rubber, that is emulsion polymerization method. There are different types of synthetic rubber. The major ones are butyl, butane, neoprene, thiocol, silicone. Butyl is a synthetic hydrocarbon rubber that is especially resistant to gas permeation. It is also resilient in exposure to extreme cold and extreme heat. It is most suitable for use in materials that come in contact with gases, ketones, acetones, and hydraulic fluids. The applications are such that they are used in automotive tires, healthcare, industry as gaskets, construction, adhesives, and etc. Next one, the Buna. Buna S is a synthetic rubber with many characteristics of natural rubber. It is water and heat resistant and is normally used in tires and tubes. Buna N is also a synthetic rubber and has excellent resistance to hydrocarbon and solvents at temperature up to 150 degrees Celsius and can be processed for resistance at low temperature as much as minus 60 degrees Celsius. Buna N is commonly known as gasoline hoses, commonly used for gasoline hoses, tank linings, gaskets, seals, and automotive transmission belts. Neoprene is a synthetic rubber that looks and feels like natural rubber and exhibit exceptional resistance to sunlight, heat, ozone, and oil. Neoprene is most commonly found in weather seals, window channels, carburetors, oil resistant hoses, and bumper pads. Neoprene is also the material of choice for use with silicate ester lubricants and freons. Thiocol is also known as polysulfide rubber. Is a synthetic rubber that is highly resistant to esters, alcohols, gasoline, water, petroleum, and hydrocarbons. However, thiocol rates poorly in physical properties like tensile strength and elasticity. Thiocol is most commonly used for aromatic aviation gasolines, gaskets, oil hoses, and seals. Planes flying at high altitude are prone to depressurization, which can cause difficulty in breathing and for passengers and crews. Depressurization can also eventually bring a plane crashing to the ground. Silicone gaskets and seals keep pressurized air inside the cabin of plane. This is the application of silicone. As a synthetic rubber, silicone exhibits excellent resistance to high heat and can be molded to fit extremely tight spaces for an aircraft seal. Applications of synthetic rubber. Rubber plays a major role in other elements and functions that are essential to flying. Aircraft fuel, known as aviation catalyzed fuel (AVCAT) and is extremely flammable. It is stored in the wings of a plane in rubber fuel bladders. Helicopters use fuel bladder tanks to store their fuel. Engines and exhausts of aircraft on ground are often with rubber covers to prevent debris from getting inside. Passengers walking from bridge to the boat. A plane often misses the flexible rubber bellows that help to bridge the gap to the plane door. In the image is shown the wheel chocks keep the aircraft stationary before takeoff. Passenger seats are often fitted with rubber mountings to minimize jarring during flight. Finally, the dials and gears used in cockpit crew are frequently mounted with rubber fittings to keep them stable when turbulence hits. So, in this session, the topics discussed were rubber, natural rubber, the process of tapping and coagulation, history of rubber, and then its applications. Then we have discussed about the synthetic rubber, its manufacturing method, that is emulsion polymerization method, different types of synthetic rubbers like butyls, bunas, neoprene and others, and finally its general and aeronautical applications. Once again, subscribe to the channel and press the bell icon to stay tuned to the upcoming videos. Thank you.